Alright, ladies and gentlemen, we're going to do 5.8. We're going to do analyzing graphs of polynomial functions. Our objectives are to graph our polynomials using our graphers. Then we're going to identify the major points, the x-intercepts, the y-intercept, local maximums and minimums, and then the turning points. Alright, so let's talk about turning points first. That's kind of our new topic. We've talked about everything else previously. So let's say I have a graph of a polynomial, and the graph of the polynomial does something like that. Okay? Well, I know it has x-intercepts. I know how to find those. Okay, so those are my x-intercepts. And then I know that's my y-intercept. But now let's talk about what happens in other portions of the graph. Notice that the slope at this point is positive, and the slope at this point is negative. So up here at the top is called a turning point because my signs change from positive to negative. And then if you notice over here, I have a negative slope kind of going down this way, and then it changes to be a positive slope. So this is also going to be a turning point. Okay? So when it changes directions. This is also called a local minimum. If you'll remember, we talked about that way earlier when we talked about our graphs of parabolas, and this is called a local maximum. Okay? All right. So the turning points are determined by the degree of the polynomial. So my turning points are going to be at most n minus 1, and n is equal to the degree. So what that means is that the number of turning points is at most 1 less than the degree. All right? So for example, let's say I have a third degree polynomial, okay? Then I would have at most 2 turning points, which is kind of what we have in our example up above. So I have roughly a third degree polynomial, and it has 2 turning points where the graph changes directions. Alright, so tonight's video is relatively short, but we do have some graphing to do on your grapher. Alright, so here's our first example. We want to identify the x-intercepts, okay, and the points where the local mins for minimums and local maximums occur. Okay, I guess I really don't need an apostrophe, but there you go. So let me give you the function. F of x is equal to x cubed minus 3x squared plus 6. Alright, so we do know quite a bit of information about our graph. I know that my end behavior is down and up because it's a cubic function. I know that I'm going to have 3 zeros, which means I'm going to have 3 intercepts. Okay? And then I also know that I'm going to have 2 turning points. So now I'm going to graph this on my grapher. See if I can get it in so you can see it. Okay, so bring in our grapher, get it where you can actually see it, and I'm going to enter our equation, x to the third minus 3x squared, and then plus 6, and I'm going to do a zoom 6 in case I've changed something since the last time I used it. Alrighty, so notice that I only have one x-intercept, so that means there's only one real value. Notice that I have a y-intercept. This is also going to be a local maximum. This is going to be a local minimum. Alright, so I'm going to sketch my graph on paper, and then I'm going to identify those very specific points. So I'll scoot this over here. So my graph looks something like that. So now I need to make sure that I identify those specific points. So the first point that I'm going to find is my x-intercept. Okay, so I'm going to do second calculate 0. Alright, and in this one I'm not actually having to find the missing zeros. Enter, enter. And I know that that point's a negative 1.196. Okay, and I'm going to label that point right there. Now I'm going to find my y-intercept because that's the next point that I come to. Remember, for a y-intercept, okay, and I'll write it down on the side just in case we forget, that means that x is equal to 0. So I can actually let my calculator do that math for me to find that exact point. So I'm going to do second calculate value, I guess you can't see my grapher, value, and I'm going to tell it I want you to find the value when x is equal to 0, and it tells me that the y-intercept is 6. So I know that that point up top is 0, 6. Okay? That point is also a local maximum, and so I'm going to identify that point off to the side. Now I need to find this little point right here, which is a local minimum. I'm going to write it right here, so there's my local minimum. Okay, now I'm going to find its coordinates. So to do that, I'm going to do a second calculate 3 for minimum. Okay, and again I have to do a left bound, right bound. So here's the left hand side, go past the curve, right hand side, and I get that that value is 2, 2. So my local minimum is at 2, 2. So this point right here is 2, 2. And then I'm just going to list my x-intercept right here, just because when you're asked to find a bunch of different information, not only is it a good idea to put it on your graph, it's also a good idea to list that information on one side of your graph to make sure that you've answered all of the questions. Alright, so remember this was a third degree polynomial. We only found one x-intercept, which means it probably has 2 more imaginary intercepts, but we're not going to have to find those today. Alright, one example down, a couple more to go, and then your problems. So it really is a very nice, short and sweet lecture today. Alright, so same idea on the next problem. I want to find the x-intercepts and my important points, my local min and max, and my y-intercept. So this time my equation is going to be x to the 4th minus 6x cubed plus 3x squared plus 10x minus 3. Alright, so again, one of the first things that I need to do is I need to graph my equation. Put it over here so you can see it. Okay, so I'm going to clear the old one. I have x to the 4th minus 6x to the 3rd plus 3x squared plus 10x minus 3, and I'm going to graph, and then I'm going to sketch my graph over here. Alright, it is a 4th degree polynomial, so it's basically a glorified parabola. So if I sketch my graph, it appears to go kind of through there, down here, and then up. Alright, so there's the sketch of my graph. This point's probably not going through the origin, but we'll find it. Alright, so it's a 4th degree polynomial, and I have 1, 2, 3, 4 zeros. Lucky me. Alright, so I'm going to start finding those zeros. I'm going to put my points of intersection on my graph. Alright, so now if I find my zeros, second calculate 0, I always start on the left. I know I'm a little bit on the compulsive side. I found that one to be a negative 1.137. Now I'm going to find my next one, second calculate 0, and I'm going to go to the left, enter, just up above, enter, enter. And this 0 right here, I'm going to draw an arrow so I can have some room to write, is 0.289. Okay. Now I'm going to find the third one, second calculate 0, go to the left, enter, 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 and I found this one to be 1.816, and then I have one more to find. Second, calculate 0. I'm going to come to the left. Should be there. Oops, I passed it. So enter, enter, enter. And this one's going to be 5.033. All right, I have a local minimum, a local max, and a local min. So I need to find those 3 points. So second, calculate. I'm going to do my minimums first. And I'm going to actually find this one. Since I'm here, I have to get my cursor. I have to find it. There it is. Enter, enter. Uh-oh, made a mistake. Go back to my graph. So I'm going to do second, calculate minimum again. The hard part, oh, I did the wrong side first. When I can't see the bottom of the graph, I'm going to pick a point here, and then I'm going to just go up here, and the calculator will find that vertex that's down here that we can't see. So enter. I did right first. That's why it didn't work. That's my bad. Oh, I passed it. This one's really hard to see. Enter, enter. All right, so the vertex that's hiding down here that we can't see is 3.962 and a negative 43, which is why we can't see it, 0.38. Okay, there's that guy. And this one's going to be a local minimum. Okay, now I'm going to find this guy up here at the top. So second, calculate maximum. And I need to go back around. I'm going to go to the left first. That's what I did wrong on the last one. Enter. Go to the right. Enter, enter. And I get that this one has coordinates of 1.108 and 5.109. And that is a local maximum. Okay. One more point to find. This little guy down here. So second, calculate minimum. You should be getting really good with your calculator about this time. Go to the left, go back to the right, enter, enter. And this one is, that point right there is a negative 0.5670, sorry, with rounding, and a negative 6.509. And this point is a local minimum. Again, it's always a good idea to label your points. So I'm just going to list them. So my x-intercepts are a negative 1.137. Then we had one at 1.816. And we had one at 5.033. I'm going to list my maximums first just because that's the word that happened to pop into my mind. And that one is 1.108. and 5.109. Only had one local maximum. Boy, that's out of focus. That's better. And then my local minimums, I had two. I had the first one, negative 0.570 and a negative 6.509. And then I had another one at 3.962 and a negative 43.038. Alrighty, so I think that gives you a pretty good idea about how to find all of the zeros. Alright, so for our next example, alrighty, this one says identify the zeros, and let's put find all zeros. Remember that means that some could be real, some could be imaginary. And then we're going to sketch the graph. Anytime you sketch a graph in this particular section, you do want to label your primary points. All right. Unless if you're told to label your local mins and maxes, you would need to do that. But usually when we sketch, we want to just label our zeros. So the first one that we're going to do, you're going to be given h of x, and it's going to be x plus 1, quantity squared, an x minus 1, and an x minus 3. Okay? So I actually know this is a 2, 3, 4th degree polynomial. I know that it's going to have 3 turning points. And I know that it has zeros, so my x's are going to be a -1 with a multiplicity of 2, 1, and 3. So I could actually get a pretty good graph before I even used my grapher. So here's my -1, there's the +1, and we'll put a 3. And the graph actually looks something like this. Okay? So if we had put our equation into our grapher, that's what we would have seen. And notice I have my primary points labeled. There's my 1. I'll move it a little bit so it doesn't look like it's part of the graph. And that would be my expectation for that type of situation. All right, so we were able to find all 4 zeros. That's nice. So then here's our next example. I'm going to have j of x is equal to x minus 4, and then I'm going to have 2x squared minus 2x plus 1. Okay? Oftentimes when you see a quadratic written out, that means that this is imaginary. It also means it probably doesn't factor. So I'm supposed to have 1, 2, 3 zeros, but I can only see 1, so I'm going to use the quadratic formula on this to find my 2 missing ones. So I would do x is equal to 2 plus or minus b squared 4 minus 4ac, and then all over 2a. When I do that math in my grapher, I would get 0.5 plus or minus 0.5i. So now I have 1, 2, 3 zeros. Okay, so my degree is 3. I have 2 turning points. And I have zeros of x is equal to 4, and then 0.5 plus or minus 0.5i. And I'm okay if you write it like that. And then if you actually put this in your grapher, I'm going to squeeze it in here so I don't have to go to the next page. If I had a 0 here at 4, and then if you graphed this one, you would see that your graph looks something like that. And remember, complex numbers do not create an x-intercept. That's why I only have the one x-intercept. All right, so now we're ready for your problems. Okay. Told you it was nice and sweet and short. All right, so I want you to identify the real zeros, which means you don't have to find the complex ones, the number of turning points, put it over here, and I would like to know the points where the local minimums and maximums occur. Okay, so you can label those on your sketch and list them. I want you to sketch the graph and label it well. Okay, all right, so you're going to have 3 of these. Number 1, h of x is equal to 5 times x minus 1, x minus 2, and x minus 3. Your second equation, g of x is equal to x to the 4th minus 3x squared plus x. Okay? And then your last one in this particular section, f of x is equal to x to the 5th plus 2x squared minus 17x minus 4. And that's actually it, you lucky dogs. So those are your 3 graphs. Identify your zeros, find the number of turning points, identify where the local mins and maxes are, and then sketch and label the graph. So good luck, have fun with your calculator, and I will see you soon.